Welcome to a lesson with Dr. Powell. Let's look at an application of the last video that we had when we were thinking about the derivative of an increasing volume function. In particular, let's think about volume being measured starting from this point onward, maybe to a point here. So think of a volume function like v of h, perhaps, where we're increasing volume here. Now, what is the derivative of this at a particular value h? Well, it would be the measure of the forefront of the growth perpendicular to it, which would be the area of this cross section. The area of this cross section, we can think, well, in the larger cone, the height is 3 and the radius is 1, meaning that the ratio of radius to height is always 1 to 3, or the radius is always 1/3 of the height, which means in this particular case that the radius would be 1/3 of this height, so the radius would be h over 3. So to find the area of this cross section, which is a circle, we simply have pi times the radius, which is h over 3 quantity squared. So what does this mean? This means that dv over dh is equal to pi times h squared over 9. Now let's put a dt in here. Now to do that, what we're going to do to this particular equation is we can multiply both sides by dh. Now, technically speaking, can we move these symbols around like that? Well, if we think at a particular instance, remembering what these things are, this means that on the tangent line to the function v of h, that dv is like the change of the y value in the tangent line, and dh is like the change of the input value on the tangent line. That ratio is always going to be equal to this. So in particular, if you're thinking about dh as being non-zero, you could multiply both sides by dh, and that would be fine in that particular case. So you would have dv and dh over here, and then you could divide both sides by a particular change, by a value, and you could call it dt if you wanted to. You could divide by anything, but what you'd get is, make sure it's the same amount of seconds that you're doing, maybe divided by 1 second or whatever you will get this relationship which exists right at this one particular point, that at dv dt at this point, so how the volume is changing with respect to time, is going to be equal to this number times dh over dt. So in particular, if dv dt is equal to negative 0.1 cubic feet per second, so we're leaking out here, and dh dt is what we're looking for, we can solve for it by just multiplying by the reciprocal of this fraction at the point when h is 2. So we're going to get a 4 pi over 9 over here, multiply the reciprocal 9 over 4 pi times negative 0.1, and that'll give us how many feet per second h is changing. Notice it'll be negative because the water level would be dropping. Thanks for watching.